In this part of the lecture, we will discuss instance methods. Instance methods operate on the object's instance variable. So these are the methods that are declared inside the class that can operate on the object's instance variables inside the class. Operations that can be performed on each object may modify the property values. So we may be able to see that the values for the variables that we have assigned initially may be modified or changed using these instance methods. As I said earlier, that maybe if you want to change your weight, so if you have reduced your weight and you want to calculate your BMI with your new weight, then you would want to be able to change your initial value for your weight without recreating the object or reinitializing the object, and we would be able to see that in a while. We typically perform an operation on one object at a time, so the methods will be called for the object and it will be operating on the variables for that object at that time. Similar to a class, a method definition has two parts, a method declaration and a method body. A method declaration names the method's access level, that is the public or the private. The return type, maybe double int string or maybe void if you do not have a return type for the method. The name of the method and the arguments inside that method. It are provided within the brackets with the name of the method. The argument specifies the type and name of each parameter, so the arguments must have the data type and the name of each parameter. The return type indicates the type of value that the method sends back to the calling location. A method that does not return a value has a void return type. So if you look at the example method, we have used methods in our example earlier, but if we look at this method over here, this is a method. The access modifier for this method is public. It does not have a return type, so we use the void for that. The name of the method is move and the takes two arguments. So this is the name of the parameter and this data type, and then we have the name of the second parameter and the data type of the parameter. As we can see, the access level, the return type, the arguments, and if we look at the example class that implements this method over here, we can see that we have the initial values for the objects of the class. So the class is ball and it has some initial values that shows the position of the ball on the screen and the color of the ball, and each object has separate values for the variables inside the class. And if you want to move the ball from one location to another location, so what you do is you can call this move method that is called message passing. In a method call, a message is passed to a receiver object. The receiver's response to the message is determined by its class. In simple words, we call the method, we pass a message to that method that what we want to do with the values of the object maybe, and what we want to do over here is we would want to call the move method that moves the ball on the screen from its initial position to a new position. So this is the object on which we want to call the method. So this is the receiver object, this is the message that we want to pass, and these are the arguments that we are passing that will be assigned to these parameters using this assignment operator, and the ball will be moved to the new position as a result of this method call. So this is how we can perform operations on the instance variables that are over here in this class. These are the instance variables with the initial values, and then we are using this method call or message passing to move the ball to the new position using these new arguments that we have passed. If we look at the complete example over here of the ball class, we have the attributes of the class that represents the internal state of an instance of this class. So these are the attributes that shows the state of the class. We use the constructor to initialize, to create the object, initialize its values as we can see over here, and then we can use the methods to implement the processing performed by or to an object upon updating its states. So what we are doing here is we are changing the initial values of these instance variables to some new values. So it will change the initial state of this object to a new state. In other words, it will change the position of this ball on the screen from its initial position to a new position using these new xy coordinate values. If there are read and write methods for an attribute x, these should be called getX and setX methods. We'll look at the setter and getter methods in a while. These are the methods that we can use to alter or change the initial values that we have provided to our object, and we can use the set methods to change those values, and we can use the get methods to retrieve those values from the class. These are usually called the setter and getter methods, and we'll try to access if we need to modify the initial values for variables, or we need to access those values or those variables, then we will be using setters and getters as well as setter methods and getter methods in our classes. So the naming convention in Java is as we saw that we use camel casing, and for the methods the first letter of the method name is in small. If we are joining two letters or two words, then the first letter of the second word is in capital letters. So if you look at the setter and getter methods, the method getX returns a particular ball object's x position to the caller. In this particular example, if you look at this one, we will be using the getter methods to return the value for a particular instance variable from our class, and we will be using separate getter and setter methods for all the instance variables of the class. So a getX method returns a particular ball object's x position to the caller. This method has an empty parameter list as we can see over here, so it does not require additional information to perform its task and return the value. So we do not need to pass anything to this method, we just want to use this method to return the value of our instance variable. Get methods are also commonly called accessor methods, since these methods are used for accessing the values of our object variables. Method setX on the other hand assigns the value of the parameter, like in this case an integer, to the class's x position instance variable. As we can see over here, thus storing the x position in the object. We see this keyword over here that we'll look at in detail in a little while, but what the set methods or the setter method does over here is it passes a new value to the class, and that new value is assigned to the instance variable, thus overwriting the value that we initialize these instance variables with when you are declaring the object. You should know that if a method contains local variable with the same name as an instance variable, that method's body will refer to the local variable rather than the instance variable. As we can see over here, if we do not use this keyword, this will be assigned to the same variable, or there will be a variable will be assigned to itself. This is called self assignment. We can avoid this kind of a situation using this keyword, since the local variable is set to shadow the instance variable in the method's body. Since this variable over here in x position, that is the parameter of the setX method is the local variable, and this one is the local variable, that is the instance variable that we declared in our class. But the problem over here is they have used the same name for the local variable and for the instance variable. If we do not use this keyword over here, we will have a situation of self assignment where the variable is assigned to itself. That will kill the purpose of our trying to change the value of our instance variable. We can use the keyword this to refer to the shadowed instance variable explicitly, and we'll see that we can use this keyword to refer to our instance variable, that is the variable that we have declared in our class, and the variable that is without this keyword inside this method is the variable or the local variable that was passed as an argument to this method. Now the scope of this variable is local and the scope of this level is up to the class. Set methods are also commonly called mutator methods because these methods change or mutate the initial values of our instance variable, so they can also be called as mutator methods. Now we look at the use of setter and getter methods in our BMI calculator class as well. If we look at this BMI calculator example again, for example, if you want to change this initial values that you provided at the time of declaration of this object, let's say you have tried hard and exercised and you have reduced your weight maybe by a few kilograms, then you would want to calculate your new BMI, your BMI value with the new value for the weight variable. Now, one way is to maybe directly change over here that will reinitialize this BMI. You do not want to do that. You want to change the value for this one variable alone. Then that can be done by providing, and since we cannot directly access these variables now, these instance variables now from outside of this class, so what we can do is over here is that we can declare certain methods inside this class that will provide us access to the instance variables and try and assign the new values to these variables. So I will first declare a setter method, maybe that you can also call the mutator method, that will allow us access to the this variable. So maybe if I declare public method, since I do not want any return type from this method, I just want to use this method to assign a new value to my instance variable. So I have declared a set weight method, and inside this parenthesis I would want to pass that value with the same data type that I have for the instance variable of the class. And I would want this value to be assigned to my instance variable, that is weight in kgs is now equal to my new weight. Now as you can see, that is doing exactly the same thing as our constructor, but now I'm able to change my initial value from outside of the class using the set method. As if I try this now, I would call the set method set weight method, and I will pass it a new value. So if my initial weight was 90 kgs and I have reduced my weight by 85 kgs, and if I now call these methods, now it should be like, if I look at this my old weight, this is my old weight, and I would want to see if this has changed. If I run this, should be able to, as you can see, my new weight and my BMI has reduced significantly as well. So I was able to reduce my BMI by reducing my weight, since I cannot maybe try to reduce my height after a certain age. So the I can change my weight, and that should be I should be able to change the initial value for my instance variables using the setter methods. Now in practice, what we would do is we will try and define the setter methods for our variables and the getter methods for all of our variables inside our instance variables inside this class. So we'll in most of our examples, whenever we declare these instance variables, for each of our instance variable will have a setter method. So I will have a setter method for my weight, and I will set a method for my height as well. And the setter methods will take a parameter that is of the same name, of the same data type that I am using this setter method for the variable that I am using the setter method, it is for this case height, and meters is equal to height. And I can also now change the value for the height variable using the object. For whatever object, if I want to change the height value for the height variable for the second object, maybe if I maybe entered my incorrect height, you can change that height at a later stage. So my initial height was 1.5. maybe if I recalculate my height, if I measure my height again, I notice that is 1.6. So I should be able to provide that new value without reinitializing this object, and I can do that using the setter method of the variable. As I can see, it has reduced my BMI as well, and it has increased my height as well. Similarly, I should be able to access these variables from inside the method, and for that we'll be using the getter methods. For most of our instance variables, we will be declaring a setter method and a getter method. There are other uses for these methods as well. Since this is a double variable, the return type should be double get weight. It does not need to take any parameters, but it needs to return a value. Since unless and until we return a value from this method, it will display an error, and I'm using this method to return the weight. Now these variables, this height variable and this weight variable, this one that we have passed as a parameter, have a scope limited to inside of this method. These are the local variables, and these are the variables that have the scope or the class level scope. So these are accessible anywhere in this class. It is why I was able to access the weight in kgs, but I won't be able to access the weight variable over here. Even if I try, I'm not able to access the weight variable over here. It is displaying an error. The reason for that is weight cannot be resolved to a variable. It is not able, my getWeight method is not able to see this weight variable that is inside the setWeight method. And the reason for that is this is variable is local to the setWeight method, and I won't be able to access this over here. Similarly, I will have a get method for my now I can see that until I return something from this method, and that should be a double value, this displays error. The method must return a result of type double. So I need to write the return statement, and I am returning the height in meters. Again, I'm not able to access this height variable since that variable is local to the set height method, and I'm only able to access the variable that I declared in the class, and that is outside of the methods. We can use the get methods to access our variables. For example, if I, instead of these variable names, and now I use the get weight method, we can use these to access our variables maybe inside this class as well. And we can, it won't make any difference to the output, but we can just show us an example of how we can use the get method. And we can also use the output for these variables. You can also the values for these variables over here as well. So if I want to maybe display the weight for this user, the initial weight for this user, before I change the value for it using the set the initial height for this user, before I change it using the set height method, and if I want to display maybe the initial value for this user using the get weight method, this one is the height and this one is the weight. So the idea is that we can access the values from inside our class using the getter methods. That is why these methods are also called the accessor methods, that these help us or allow us to access our the values or return the values for our methods. So our instance variable. So this one displays us your initial weight is maybe your initial weight was whatever the message you want to display, and returns the value for the weight in kilogram for us using a call to the get weight method. And similarly, you can return the height, that is your initial height is, or your initial height was in 0.5, that we provided using the constructor call, and then we change that value using a call to the set height method, and we pass that value as an argument, and we can see that that value has been assigned, and the calculator is now based on the new value. So this one is an example demonstration of how we can use the set and get methods. Now let's look at how we can use this keyword to differentiate between our local variables and instance variables. Now this keyword, or using this keyword within an instance method or a constructor, this is a reference to the current object, the object whose method or constructor is being called. So for example, if I'm using this keyword with the variable, this means that this is an instance variable, and the variable that I'm not using this keyword with may or may not be the instance variable. But if I'm using this keyword with a variable, that means that this is a variable or a reference to the current object, that is the object that I'm calling or using this instance variable of. And this is useful in situations where we have the same name for our local variable and our instance variable. It allows us to differentiate between the local variable and the instance variable. So the variable that has this keyword with it, this dot, the variable name, that is the variable of the object, that is the instance variable that I declared in the class, and this one is the variable that I have passed as a parameter to this object, to this method or to this constructor. And this is local to this constructor, this one, and the one with this keyword is the instance variable that I have declared in the class. Same is the case with the y. Now if I do not use this keyword over here in this situation, I will have a problem that there will be a situation of self-assignment. That is, I will be assigning the value the local variable to itself, and the reason for that is the local variable takes precedence over the instance variable if they have the same name. But if I'm using different names for my instance variables and local variables, then I can maybe avoid the using this keyword, and this is what we have been doing so far. But in our practice we'll be using this keyword so that we are always sure that maybe if somebody changes the value for local variables, then we are sure that we are accessing our instance variables where we are trying to access the instance variables. And in our practice we'll be trying to use this keyword as much as we can. Using this with a field, when an instance variable and local variable share the same name, you must differentiate between the two by prefixing the instance variable access with the use of this, as we can see in these examples. Using this with a constructor, we can also use this with a constructor. One constructor can call another by using this. So if we have multiple constructors in our class and we want to call one constructor from another constructor, then you can use this keyword. Now if we have this point constructor over here that takes no parameter, and if you use this and provide with two values as arguments, this will call the constructor with two parameters, as we can see over here. So we can call one constructor from another constructor, and what will this will do over here is, this is an empty constructor, maybe it does not take any parameters, but what it will do over here is it will call the constructor with two parameters, and it will initialize the values for these variables using whatever the values we pass to that constructor. So we can use this keyword to call one constructor from another constructor as well. So when an object is now initialized using this constructor, the constructor with no arguments, what it will do is it will call the constructor with two arguments, with two parameters, and it will pass these values to that constructor and initialize the values for these variables to 0, 0. You can look at this example exercise and try to find out the output. We'll look at our example that we have been discussing so far. So if you look at this example, we try to use this keyword, and currently we are using different values for our different our local and instance variable, but I would want to be able to use the same names for these two variables so that I'm sure that I'm assigning the exact same variable to the intended instance variable, and for that purpose I might want to use the same names for the instance variables as well as the local variables that are holding the values for these instance variables. And similarly, I would want to change the height in meters. So now our variable, the names for our local variables have changed, and what I should be able to do is I should be able to assign in meters. Now what happens over here is we do not get a compilation error, but we get a warning over here, and the warning is that assignment to a variable that carries has no effect. It has no effect since we are doing self assignment error here, and we can ensure that we are assigning the local variable to an instance variable is that I can use this keyword over here. Now it will differentiate between the two. Now this one is a variable of the this one is an instance variable, and this one is my local variable, that is this one is my local variable. It has no this keyword with it, and this one is my instance variable, that is the variable that I have declared in the class over here, and this one is variable that I have passed as an parameter to this constructor. We can do the same for my other variable as well, so that I'm sure that I have assigned the values for to my instance variable. You can also use this initialization to do some basic validation. So for example, if I want to make sure that I have a valid value for my weight, then the initialization should happen, otherwise it should not happen, and I should want to do the same for my height as well. So I want my minimum height and my minimum weight and height to be greater than 0. So now I won't be able to pass a negative value to these variables. So let's try and check. The output is the same since we have done our initialization right. If I now, like say, pass a negative value to my weight variable over here, since I am not trying to validate this value in my setter method, and let's see what it does to my calculation over here. Now my weight is negative and my BMI is negative 29 minus 29, and we cannot possibly have negative weight. Maybe there is no possibility that our weight can be less than 0. So we need to ensure that our user is entering a valid value, and we can do that, and that is where these constructor and this setter methods are helpful as well, that we can use these to ensure that we are getting a valid value from the user, although we were assuming this initially, but now we need to make sure that we are getting the valid value from the user. Now if I do not provide a valid value over here, the value for the weight might be initialized to 0. Let's see what the output now is. Now my as we can see over here, I provided a negative value over here, and what the program did for me is it did not change the value for the weight variable now, since I provided this statement over here that my weight must be greater than 0. And what it did was, since I provided a value that was less than 0, and what it did was it retained my initial value that I have provided using the constructor. It returned the value to 90. That was the value that I provided initially, since this value that I provided afterwards was less than 0. And in my validation, I have asked the program to check if the value is greater than 0. Only in that case this assignment will be performed, otherwise this will remain the same as my initial value. So we can do some basic validation using the setter methods and the constructor as well, and we can also use the this keyword. We would prefer to use the this keyword to refer to our instance variables, and we can also do this validation and my setter method. For my height as well, so that I'm sure that at least I'm providing a valid value. There can be more validation that can be performed. Maybe we cannot possibly have too high value for a parameter for a height, but the minimum is that we should not have a negative value. And we'll also have a look at some built-in method that we can use to print the value directly, the output directly for an object. For example, in this case I was using I was calling the display method over here. I was calling the display method for my object to display the details for that object. Now what Java provides us is it provides us with a built-in method that we can use to directly print our objects, and this is what we'll be trying to use in our practice. This is called the toString method, and the toString method returns a string, and it allows us to format the output of our objects in the form of a string, and return that formatted string whenever or wherever we print our object. So this is the last thing that we will do in this lecture, and we'll look at the toString method again in our future lectures as well. But this is how we'll try to print the objects of our the details of our objects we'll be using, and we will be using this toString method to format output of our objects. Now the string.format method is used exactly the same way as the printf method that we were using to format the output of our the format that we were using to format our print output using certain format specifiers. We can use the string.format method to give a certain format to the output of our objects, as we can see over here that, let's say I want to print the weight over here. I maybe use %2f for it. I would want to go to the next line. and I want to use again %.2f, so that it gives me output with two precision points. Or here I'm using the printf method, or in my toString method I'm using the string formatted to get exactly the same output. I can use the /n over here, or the %n over here, and I can also display the value for my BMI %.2f, and then maybe I want to go to the next line. And after the comma I will provide the values exactly the same way as we did using the printf method. So I will use the get method, the get height method, and since I do not have a method for the BMI, so I will use this to return the value for the BMI. And in our output now we'll try and see that how does it display the output for me now. I'll go to the client method, and over here I will just give a statement so that we can differentiate between I'll just provide a statement over here, and the toString method. Now the toString is a built-in method, and we'll be using it with the same format as provided over here. It has a string return type, and it should return a string. Now this will return the output of or the details of our string, our object in the string format. What we can do is we can simply print our object, and we will be able to get the output or the details of our object. So if I, let's say, maybe try and remove this statement from here, so that I have the output for this one object, and if I try and run this one now, so using the output using the toString method, as we can see over here, is it provides us exactly the same detail, but over here I'm just printing the object, and in my previous case I was calling these different methods using the object. So we can simplify the process by simply printing the object, and we can use the toString method to get all of the details of our objects in the format that we have specified. And we can use the format specifier the same way as our printf method, and you can see that is exactly the same as our printf method, just the name of the method has changed, and it returns the details of our object using the toString method, and if I now just print my second object over here, mi2, I should be able to retrieve all of the details of my object. As you can see over here, this is the details for my second object, and these are the details for my first object over here, and we are able to retrieve the details of our objects using the toString method.